You may have remembered in elementary school, your teacher may have told you, hey, rub your hands to keep warm. Or maybe that was their explanation of friction. That heat building up because there's a rubbing going on. Now, we're going to take a look at what is friction. We're going to look at more of a scientific take on it and give you a lot more examples. So first off, friction, what is it? It is a force. We don't always think of it as that, but it's a force that keeps objects not moving. So maybe the friction's so great that the objects can't move. Think of Velcro if that helps you out. Or it's a force that slows down two objects from moving. Now, if we were to zoom in on two objects, okay, we're actually going to see they're not perfectly smooth. There's particles, and those particles rub or bump against each other, and that's what we call friction. Now, different objects have different amounts of friction. Now, if we're thinking of two objects or particles rubbing, it is a contact force. That means there's contact being made between the objects. Now, those objects might be solid, okay, maybe a roadway, a tire, maybe it's rubber hitting the road, whatever it is. It could be a gas, so it could be particles of air that are rubbing against each other. The easiest one I think about is when you stick your hand out the window, right, and your hand, you're feeling all those air particles, right? You might be going up and down out the window. That's friction caused by air. So it could be a gas, it could be a solid, or it could be a liquid. Okay, I think about when wakeboarding or water skiing, right? If you fall, right, you're gonna be hitting the water, you're skipping against. You might feel that friction really, really quickly, right? It hurts. So where does friction matter to us? Okay, so great examples where we want a lot of friction and some great examples of where we actually want very little friction. Let's start with the ones where we want a lot of friction. These are situations where we want to slow down, we want to stop, or we want to stay in one place. Okay, first up, I think about, we just hung a picture, right? And we use Velcro, where we hang the picture on the wall using Velcro, and that Velcro sticks, right? It keeps the picture from dropping off the wall, right? So there's a lot of friction there. Next up, I think about a car that wants to slow down or wants to stop. Maybe it's coming up to a red light, or maybe a ball, came across the roadway. We want to stop. So what we do, we apply our brakes, right? So we have a tire, we apply our brakes to it, and our goal is to slow down. So if we have a lot of friction, we're going to stop quicker. Okay, you might want to think about the mechanics of a bicycle. You might imagine that brake pad hitting the rim, or maybe the disc brake, right? It's going to squeeze and it's going to stop that bicycle tire. Okay, another one, when we talk about, I like roller skating, right? Or rollerblading, right? So you're picking up a lot of speed, you're going downhill, you're like, oh wait, hold up, I need to slow down. It's getting a little out of control. So if you have that wheel brake, the brake on the very back, right, the heel brake, you're going to press your heel down and that back rubber piece is going to rub against the road. You want a lot of friction there. Okay, so maybe you can think of some other examples where you want a lot of friction. Maybe if you're an ice climber, right? For example, you're climbing a frozen waterfall. You want that pickaxe, right? You want a lot of friction when you dig in. Okay, and that goes for a lot of different examples. If I'm climbing a mountain, you want a lot of friction with your boots to get a lot of traction so when you're climbing, you're not going to slip off. Okay? If you're rappelling off a mountain rope, you want a lot of friction between that rope and that carabiner. So let's look at the flip side of that. So situations where we don't want a lot of friction. If we stick with kind of this winter theme, right? If I'm sledding, I want as little friction as possible because I want to build that speed. I don't want anything gripping, right? A lot of professional skiers, right? They spend a lot of time looking at different waxes on the bottom of their skis so they can limit the amount of friction, right? Less friction, I'm going to go a lot faster. It's kind of like the sliding action, okay? If I'm somebody who's a cross-country runner, okay, I want some friction, but I don't want too much, right? If I'm digging in every single step, right, it's like kind of like pulling yourself out of mud, right? You don't want to have enough traction, but not too much, right? And that's a nice, good balance here too. If I think about baseball or softball, if I'm sliding to a base, I don't want too much friction. If I do, one, I'm going to rip my pants, my socks, but two, I'm just never going to get there, right? If I'm able to slide, I'm going to slide really easily to that base. So I want to limit kind of how my body is with the friction. All right, so something to think about. Okay, so when we talk about this, again, it's a contact force between either solids, liquids, or it might even be a gas. Now, when it comes to measuring, okay, there's a lot of science to it. There's a lot of different numbers. We use this Greek symbol called mu, right? It kind of looks like a U, and it looks kind of like a crying or a teardrop U. It's a Greek symbol, but it stands for the coefficient of friction. So what does that actually mean? It's a number that represents how much friction there is. Okay, so if I'm thinking of, hey, concrete, okay, so maybe a sidewalk, and I'm comparing different things rolling across it or moving across it, right? So if I'm dragging rubber across it, or if I'm dragging glass across it, right? So if I'm comparing, right, those numbers are what we call coefficient of frictions, right? So that's super important. Again, if I go back to that professional skier, that's important when they know that the coefficient of friction for one wax is different than another. They can actually figure out, hey, this is the better product. Okay, so there's a lot of science behind it, and that's not just for skiers. You can go into engineering. You're talking about bearings and maybe skateboards, bearings and machines and conveyor belts, elevators, where you want to reduce a lot of the friction, so you might use a different product. You might use a lubricant or an oil. Okay, imagine if your engine of your car had too much friction with the pistons and cylinders, right? Your car wouldn't run efficiently. So we actually want to limit a lot of friction and different things. And doing so can save a lot of time and a lot of money and a lot of effort and force. Now, a term that does come up is something called dry friction. This is typically a situation where you have two solid objects. Take, for example, a train track, right? On top of that train track, you're going to have a train wheel, which is solid. Okay, so two different metals, and there's a solid friction there. Okay, so just something to think about. Dry friction, again, is two solid objects, right? If we're talking about, hey, the object's so, there's so much friction that it's not moving, we call that static friction. Okay, remember like the static charge when you rub your hair? Okay, same idea, but the idea is that there's so much friction the objects aren't moving, or it takes a lot more force to get it to move. Okay, so for example, we were to go outside and there's a box laying in the grass. Okay, we try to push it. Okay, it takes a lot of force to get it to start moving. Okay, if you think back to Newton's first law, the law of inertia, right? Objects want to stay at rest. So static friction is actually usually greater than when the object starts moving. Once I start getting that box sliding across the grass, that's where we're turning to what we call kinetic friction, or what we call sliding friction. So when the object is moving and there's still, again, it's slowing down because of friction, or it's rubbing against it, right? That's where we call it sliding or kinetic friction. So hopefully that helps you out. Two really useful terms. When you take a look at today's lab, you're going to see those terms come up, because you're going to see the values when we have a force gauge, when we start moving objects against different surfaces. The last story I have for you guys is the Forbidden City, which was an ancient city back in China that was built out of these massive, massive blocks of stone. Now, if we kind of go back, even engineers and physicists are trying to figure out how do they move these giant stones. It would take hundreds of people, and to actually push it through dirt, okay, that wouldn't actually work. If they're pushing it down a concrete road, it still wouldn't work. They weighed so much. So how do they build an entire city out of it? So we go back to look at the friction of it, right? We talked about, hey, using a road, dirt path, too much friction. How do you reduce that? Okay, so the first thought was, maybe we have some sort of cart or some sort of wheel system. Okay, now even with modern technology, it was so much weight. So what they thought, maybe they used tree trunks, right? Picture kind of like a skateboard, right? Just trying to skateboard on just the board in the street. Okay, it's not gonna work. So what do? You add wheels. The same idea, they thought maybe if we add logs underneath and we roll them, kind of like having pencils kind of laying on a desk and having a book go across it. Okay, a lot easier, a lot less friction. But that still wasn't enough reduction. So the next idea was, they went back, they looked at the temperature, they looked at the weather, they looked at kind of the climate of the time, and they thought maybe they could freeze the roads. Now think about it, if you've ever pushed something across ice, okay, or maybe you've tried to walk on it, not a lot of friction, not a lot of traction there, so you probably fell. So the thought is maybe they used these giant stones, they did push them across ice. Now, they actually figured out there's a way to actually do better than that. The idea on top of these frozen roads is to add a layer of, that's right, water. So they actually have a small time window, a time frame, where if they put water on top of the ice, they can actually move the stones even more efficiently. And so this is the kind of the thought behind it. How did they build the Forbidden City? They froze the roads, they added a little bit of water on top, and then they were able to move these massive, massive stones to build this city. So hopefully kind of when you're going through everyday life, think about it. When is it important for me to have a lot of friction? Where is it? And we'll see you next video.